This video will be part 2 of the video series on developing the new versions of the Automated Accu-Slice System for slicing boards on the bandsaw. In this video, I'll be describing the design, the development, the machining, and the assembly of two models of this new Automated Accu-Slice System, both a 36-inch long model and a 48-inch long model. I could have not accomplished the design and assembly of the system without the addition of the CNC mill to my shop. In order to machine the parts for the Automated Accu-Slice systems, I had to first design the parts using the SketchUp software and then program the machining using the Centroid Intercom software. The parts were all then machined using the Precision Matthews mill that I had converted to CNC operation, as described in several of my other videos. The first 10 minutes of this video describes the actual machining of several of the components, including the front and back plates, the guide bar locking mechanism, and the miter bar locks. If you just want to view the assembly and testing of the Automated Accu-Slice frame, then just jump to around the 10-minute point in this video. I spent a good week and a half just machining these parts. Not shown in this video is the additional machining I did for the fabrication of the miter bar and the adjustable legs for the table. The Automated Accu-Slice systems described in this video series are prototype designs, and the design will change depending on what problems or issues arise during the development. I did make a few design changes to my original concepts, which are described in the latter portion of this video. I'll start with the drilling of the mounting holes in the front top plate. Next, I'm drilling the holes that will be used to mount this front plate to the linear bearing. There's 3 steps involved. First of all, using a center drill to mark the centers for all my 4 holes. And then I drill a 0.200 inch diameter hole through the plates that the screw will go through. And I'm using metric screws. These are 5 metric screws. And I'm using a 0.200 drill to drill the whole way through. And I'm using the pecking technique to drill these holes. And I repeat this process on both sides of this plate, and also repeat it on the 48-inch plate. Next, I go to my 3/8-inch mill and counterbore the holes. This will set these screws below the surface of the plate. All the milling shown in this section is actually shown here at 5 times the actual speed, just for viewing purposes. And that's the final plate as it comes off the mill. Next, I'll drill the mounting holes in the larger back plate. This shows the large plate sticking through the side of my mill cabinet. I had to cut that hole to enable it to fit on my mill. And then I use the same process to drill the 4 holes to mount this main front plate, or actually the main back plate, onto the system. And again, there's 4 holes, the same process, doing a center drill to mark the points of the holes, then using a 0.200 inch drill to drill completely through, and then finally using a 3/8-inch mill to counterbore the holes. This cutting process was then repeated on the opposite side of this plate, and then I also repeated this on both ends of the 48-inch long aluminum plate for the 48-inch Accu-Slice system. And what I'm showing here in about less than 3-4 minutes, actually I spent a whole day doing this. I spent quite a bit of time setting this up, making sure it was accurate, making sure that the holes were perfectly aligned from one end to the other, because I didn't want to get any binding of these plates when they slid on the guide bars. So I completed drilling the holes for these plates to mount them to the linear bearings, and the holes are drilled and countersunk, and these are metric screws that hold this plate to the linear bearings. And the heads are countersunk or counterbored so that they stay below the surface of the plate here. But these ride really smooth. In fact, I can push it, and it rides much smoother than our standard Accu-Slice system. And this is our 3-foot model, and I got similar results on the 4-foot model. And there's a lot of weight in this plate, and look how smooth that thing is. So the next step is to start building the blocks for this. I have a block which would go up front here. This would be my locking block. So that needs to be milled. And the block back here will be the block for the miter bar. So I'll start machining that next too. So that's the next step, is to machine these blocks. This is a schematic of the locking block for the Automated Accu-Slice system. The purpose of this block is to mount to the front plate on the Automated Accu-Slice system and then lock it to the guide bars. I'm starting out with a machined aluminum block, 2 inches long by 1 1/4 inches tall by 0.6 inches wide. So I first use a center drill and then use a series of drills to drill a final hole with a diameter of 5/8 of an inch. The final step is using a 16 millimeter diameter reaming tool to ream the hole to exactly 16 millimeter diameter. The block is then turned 90 degrees in the vise on the mill, and then 3 holes are drilled in the top surface of the block. The outer 2 holes will be drilled 0.200 inch diameter, and these holes will be later tapped with a 1/4 inch 20 threads per inch tap, and these will be used to mount this block to the top plate. The center hole will be drilled to 3/8 of an inch diameter, and this hole will be used to insert a 3/8 inch diameter brass spacer, which will be used to lock the top plate to the guide bar. And this is the finished drilled block coming off the mill. As a final step, I'll tap the 2 outer holes with a 1/4 inch 20 thread per inch tap. The tapping operation is not shown in this video. The final machined locking block is then slid on the 16 millimeter guide bar. A 3/8 inch diameter brass pin is then inserted in the center hole, and then 2 number 5 metric socket head screws are used to screw the block to attach it to the top front plate. Notice that 3 additional holes have been drilled in the top front plate, very similar to the holes that were drilled previously. The outer 2 holes are drilled and countersunk for the metric screws, and then the center hole is drilled and tapped for the 1/4 20 thread per inch thumb screw. The 7/8 inch square front bar is then inserted onto the 16 millimeter guide bars and then locked in place with the 1/4 20 thread per inch set screws on the ends. Next, I test the locking blocks to see how tightly it locks the system to the guide bars, and it actually works quite well, and very little finger pressure is required to lock it in place. This is a schematic of the guide bar support block, which will be machined in this section of the video. The large hole in the center, which is actually 16 millimeters in diameter, is for the guide bar to go through. A dado will be cut in the top front corner of this block, in which the miter bar will be inserted. This is for our standard 3/4 inch miter bar, but this block will be machined for other size miter bars in the future. Once again, I'm starting with an aluminum block 2 inches square by 1.5 inches tall, and the first step is to drill the 16 millimeter hole in the center for the guide bar. Again, this is done in the same process as done previously. First of all, using the center drill to mark the hole to be drilled, and then using a series of drills to drill the hole to 5/8 of an inch diameter, and then reaming it with a 16 millimeter reamer to get it to the actual 16 millimeter dimension. Next, the block is turned 90 degrees in the vise, and then a 0.200 inch diameter hole is drilled in the center of the block. This hole will later be tapped with a 1/4 inch 20 thread per inch tap, and that'll be used to insert a set screw, which will be used to lock this block to the guide bar. The block is once again turned 90 degrees in the vise, and then I'm using a 2 inch diameter facing mill to mill the dado in the front edge of the block. This dado will be used to mount the guide bar, and right now I'll be using it to mount a 3/4 inch miter bar, but other size miter bars will be machined in these blocks in the future. Next, I need to drill 2 holes in the block, which will be used to mount the miter bar. And I am drilling 2 holes. Each of these holes will be drilled with a 0.200 inch diameter drill. These will later be tapped with a 1/4 inch 20 thread per inch tap, and then they'll be used to mount the miter bar to these blocks. And here's the finished machine block. And the next step will be to tap the 2 holes in the top and the 1 hole on the side with a 1/4 inch 20 thread per inch tap. I just finished machining the miter bar for the system, and then I assembled all the components together and attached it to my bandsaw table. And I did a couple things different. Instead of using the offset cams on my miter bar, I'm actually screwing the miter bar into the bandsaw tabletop. So after I drill the holes in this miter bar for these screws, which are countersunk flathead screws, I then drilled and tapped 2 holes into my bandsaw table. And actually tapping and drilling into the bandsaw table, which is cast iron, is very easy, so it's not very difficult at all to do. I did it by hand. So I assembled the system. I attached the miter bar to my end blocks, attached to my guide bars, and also my front mounting bar here, and then my 2 plates. And these plates do run smoothly, except that now my miter bar is actually below the top of my bandsaw table by about 30 thousandths of an inch, which means this table now is sliding on the top of the bandsaw table. So I need to adjust the height of the bandsaw table. And I do that by remilling these slots into these blocks for the miter bar. And that difference is about 30 thousandths, so I had designed it such the bottom of this table was level with the top of my miter bar, so now I need to increase that distance by about 30 thousandths of an inch. So let me go and remachine these blocks. I'll take off 30 thousandths in depth, and then it should be perfect. The other issue that came up is there's so much weight on this outside edge of the table where it overhangs the bandsaw table that the system is actually sagging. And that's one of the reasons I decided to screw this miter bar into the bandsaw table to make it more secure so it won't flip out on you. But I said there's so much weight on this outside edge, I need to support this end of the Accu-Slice system. So I'll be machining 2 bars, 1 on each side. These will be adjustable legs that I can adjust the height of this to eliminate any sagging of the index table. And I haven't even added my indexing systems or my servo motors, so they'll add even more weight to this outside edge. So it is important that this system be supported on this outside edge to make sure everything slides smoothly. Because right now this table is sliding on the bandsaw table because it's below the top of my bandsaw table here. So I need to remachine these to make that adjustment. Well, I have it adjusted pretty good now. You see how smoothly it slides. What I did find out on my bandsaw, my bandsaw blade goes in like this, and so there's a slot in the table. And this side of the table is about 3 thousandths higher than this side. So I sanded it down a little bit, but it's still a little bit higher than this side. So that's where it's just barely scraping. But I adjusted these. I took off about 40 thousandths of an inch. And what I did, this is a spare block. Where the miter bar mounts in here and my guide bar goes in here. And so I took off about 40 thousandths off this depth. I moved it down 40 thousandths. So this miter bar was about 35 thousandths below the tabletop. So I took 40 thousandths off here, so I have about 5 thousandths clearance. And I did a measurement using a feeler gauge, and I have between 3 and 5 thousandths of an inch. It does hang up here, so here it's a little bit closer. So that's where it's rubbing, is right in here, maybe just a hair. But I want it to be close because I want my magnets to go in here, and the magnet's got to pull it down and lock it in place. But, I have between 3 and 5 thousandths and maybe a little bit less here. But you can see how smoothly that cuts. So now you can see how smoothly that slices. But I do have a spacer underneath my leg here, and if I remove that spacer, then it no longer slides. Because there's so much weight on this edge of the table. So my next step is to make some support legs. We'll be making 2 legs, one for each side, and they'll be adjustable so you can adjust the height to get it to the exact height you need it. But once that's set, the system will work fine. So the next step is to make these legs, and then I'll start working on the other parts for this, the electromagnets and the rail and the guide bar and everything else has to go on the top here. So. Okay, in a likewise manner, I just assembled the 4-foot table, and this is actually sagging on both ends because it overhangs the bandsaw table so much. So this is probably actually going to require 4 legs. You know, one here, and then one here and one here, just to prevent the sagging, because it definitely does sag. There's a lot of weight on this. So I'll be making 4 legs for this, I guess. So we'll give that a try then. It's riding with its sliding on the table, and when I put a feeler gauge on it, you know, I got clearance in the middle, but on the edge it's hitting the table. So it's hitting the table here and here, but it's clear in the center. So that'll be another project doing 4 legs. I just completed the development of these extension legs for the Automated Accu-Slice System. And I made 4 of these legs, and they are adjustable. This top piece here is adjustable, has various tapped holes in it, so I can raise this up and down. And on the bottom foot is an adjustable foot to raise and lower the table. And this mounts on the guide bar on the Accu-Slice system, and then locks in place with a set screw. By having 4 of these legs now, I can actually adjust all 4 corners of the Accu-Slice table to get it perfectly flat and setting nice and straight on the bandsaw. And by adjusting these to the correct height, I now have clearance between 3 and 5 thousandths between the table on the Accu-Slice system and the bandsaw table. So this system slides very smoothly now on the bandsaw table. There's no scraping, and I can raise or lower it a little bit using the adjustable feet if I need to adjust it very slightly. But I adjusted all 4 corners, so it's riding above the table here and also out here. I said between 3 and 5 thousandths of an inch. I made one other change too. I actually raised this front bar. I put a spacer in here around 50 thousandths of an inch to raise this bar actually above the table a slight amount. This piece of metal on this 48-inch bowl has a slight bow in it, and this now keeps it completely free of the not hitting these extension tables on the bandsaw. And it's not important that this be perfectly level with this front plate. This front plate is what determines how everything aligns on your bandsaw. This is just for the mounting of the indexer systems that will be adjusting the in and out movement of the table. Now this completes the design and development of the frames for both the 36 and the 48-inch models of the Accu-Slice system. In assembling these systems, we learned quite a few things, and we actually changed a few ideas in our design. First of all, these tables are much heavier than I suspected, and as a result we had to add the 4 legs to enable the table to be perfectly aligned with the bandsaw table. In designing the system, we included these 16mm guide bars with the larger linear bearings. These larger linear bearings run much smoother. My tables run very smoothly across the table on the bandsaw, and because they're larger, they don't twist and turn like some of the others, so they're much more stable. As a result, they should give more accurate cuts when slicing boards on the bandsaw. So those are the major changes, going to the 16mm guide bars with larger linear bearings, adding these legs to the 4 corners, which are adjustable, so we can adjust the system so it rides perfectly across the bandsaw table. So there's no more dragging of this table on the bandsaw, like you may have seen in some other videos we've done on other systems. And I can put a heavier board on here and it will still slide. And if it's go down too much, I can always raise the legs a little bit to increase its height. So definitely are adjustable, and that's a major advantage to this new design. Overall, the frame is much sturdier than our previous system. This larger front bar gives it more stability, and the guide bar is actually mounted with 4 screws to hold it firmly in place on the ends of the guide bars. So that's definitely much more stable. And this guide bar can be changed to other guide bars with different dimensions that will fit in other bandsaws. One of my first projects coming up will be to adapt this to fit to the the felder and the hammer bandsaws with a thinner rail, which will screw into the bandsaw tabletop. And that's the other major change we did. Instead of using the offset cams to mount this rail to the bandsaw table, this guide bar is actually this miter bar is actually screwed into the bandsaw tabletop. So this required drilling and tapping 2 holes in the bandsaw table, but that was very easy to do, and it's much more stable, and there's no chance of this thing flipping on you as you're operating it. One other thing that will be required for these systems are these table extensions on the bandsaw table. The normal bandsaw table is about maybe 6 inches from the bandsaw blade, and you need a little bit more. There'll be electromagnets on here, and so these cast iron or these iron plates will enable the electromagnets to clamp this table in position when you're ready to cut boards. So these extensions will be required for this system. For the Laguna, this will be 2 separate plates. When I get my hammer bandsaw, it'll be a single plate the entire length of the bandsaw table. So that completes this part of this video for this assembly of the frame for the system. In the next video, I'll go into the next steps, adding the linear rail, the Accu-Slice rail, the linear ball screw, the stepper motors, or actually the servo motors with the indexers to move the table. And those indexers will be placed one out here and one out here. So instead of on a previous system where you have a single indexer in the middle, you can have twisting at the ends. By mounting these 2 indexers on both ends, they'll both move accurately. So they'll move nice and straight, and there'll be no twisting of the table as it's moving. So that should be an improvement to give you better accuracy when cutting boards on this bandsaw using the Automated Accu-Slice System. In conclusion, I want to thank you for once again watching this video. Going forward, I'll be concentrating on the 36-inch model of this Automated Accu-Slice System. Just to concentrate on developing one system. If I make any mistakes, I can correct it, and parts are less expensive on the shorter system, so I can always change it. And after that design is complete, then we'll finish the design of the 48-inch model. However, the completion of this system going forward for the next few weeks is going to be a little bit delayed. I have a couple other projects in the works. First of all, I'm getting a new hammer model 4400 bandsaw, which I want to adapt this system to. And that's due to arrive in the next 2 weeks. That'll be installed right here. I actually made a room in my shop for it. This system will be moving over to the side or to the other end of the shop. And I'm going to create a big area where I can cut larger boards using the hammer bandsaw. In addition, I want to adapt our standard Accu-Slice system to fit both the felder and the hammer bandsaws. We've had numerous requests for these over the years, and I didn't have the machining capability to do the modification myself. But once I get that hammer bandsaw in the shop here, I'll be making some new miter bars to adapt our standard Accu-Slice system. So our standard Accu-Slice system will fit on both the felder and the hammer bandsaw. So that's a major project which I need to go forward. Also, I'm working on another video on the Accu wedge, cutting some different widths of segments and wedges. So that project I'd like to complete, get that done in the next week or 2. Also, it's springtime, and my other hobby is gardening. And I've already started my garden. I have it dug up already, but I have a lot of work to do. Getting my tomatoes and onions planted probably next week, and then starting my tomatoes and peppers, which I start from seed. So I have a lot of work to do on that too. So I have other projects besides just doing this, but this will be done this year. The plan is to get the structural components done in the next say 2 months, and then I'll be spending my time on the software development. So once again, thank you for watching this video. If you have any questions or concerns or comments, as always, please give us a call or drop us an email. We're always happy to hear from you. And once again, thank you for watching this video.